In this problem, we're asked to solve for r, and so I'm going to move some of the terms around a little bit. I'm going to take the terms on the right and move them over to the left. I believe I copied the problem down wrong, which is kind of silly. So in essence, I've subtracted a from both sides to get 0 on one side. That's a prerequisite for using the quadratic formula. And then I want to solve for r, and I have an r squared term, an r term, and a no r term. So in using the quadratic formula, we have to decide what a, b, and c are going to equal. A is the coefficient of r squared, which in this problem is pi. B is the coefficient of r, which in this problem is pi times s. And c is the remaining non-r term, which in this case is the opposite of a. So we have x equals the opposite of whatever b is, minus, plus or minus, the square root of b times itself, b squared. That'll be pi s times pi s, that's pi squared s squared, minus 4 times a times c. A times c is negative pi times a. The negatives will cancel, and I have pi times a, all divided by 2 times what a is, and that's 2 times pi. So this would be my answer. I should really say that these would be my answers. And since we're talking about the surface area of a cone, and we're talking about r, not x, r, being a positive number only, this minus sign seems a little strange. It doesn't really match the reality of the problem. And so, since these are physical quantities that really can't be negative in any known world, this single solution is best. We're told in problem 30 on page 724 that this is the equation that's going to govern the action in the problem. But before you can use an equation like this, you have to know what the variables represent, and it's got to be very specific. One way to do this is to look up the examples in the textbook that are like this, and those examples in the textbook will tell you what the variables represent. Another way to do it is to let your teacher tell you. So I'm telling you that in this problem, t represents time measured in seconds, and s represents the distance traveled in meters, and v naught is the initial or starting downward velocity or speed in meters per second. And so now we're given some numbers to put into this equation, and we're given one thing to find out from this equation, and maybe we'll use the quadratic formula, maybe not. If we're solving for t, we would probably end up using the quadratic formula. If we're solving for v naught or s, we probably wouldn't. So let's put in the numbers and find out what we get. We get 4.9 t squared, that's 4 squared, plus v naught, which we don't know, times 4 equals 91.2. That's 4.9 times 16 plus 4 times v naught equals 91.2. At any time I can grab a calculator and do these calculations, but I'm going to take this amount away from both sides, so I'll have 4 times v naught equals 91.2 minus 4.9 times 16, and then I'm going to divide both sides by 4. And again, you can grab a calculator and do that calculation. I don't happen to have a calculator handy, and I don't feel like standing up. So I'm going to distribute the 4 to each part. And again, anytime you can grab a calculator, that would make a lot of sense here. I'm just stubborn, so 4 goes into 91.2 some amount of times. Let's see if I can do it. 2 into 11, 232.8, I believe, minus the 4 goes into 4 once, the 4 goes into 16 4 times, so I have 4 times 4.9, which would be 19.6, I think. So, subtracting these two, we should find that the initial velocity is 3.2, and I said that would be in meters per second, so I will believe myself. Meters per second, and we should be done.